Hello again. In the last class we learned about JWT and specifically the HMAC based signing. I did go over quite a few details in the last class, but also skipped over or glossed over some of the details as well. For example, we talked about different algorithms that we can use here while signing it, but it also allows us to skip the signing algorithm as part of the verification. For example, if I don't necessarily specify any of the algorithms here, the signing will still go through fine. So let's try and see if this executes just fine. Let me re-execute this. So if you see here, the signing went through fine, as did the verification, right? The verify call went through fine, even though we didn't specify the algorithm. This is actually a problem. This can lead to what are called signature stripping attacks. So whenever we do the verification, it is imperative that we provide the algorithm, otherwise it can really put everything to naught, whatever we are trying to do, right? So I go back and then stick that in again and see if this works fine just even after that. Yes, it does, right? And another thing that we wanted to also throw light on was the fact that we can also provide additional headers here. For example, let's say I want to have the token valid only for 10 seconds, let's say. I don't want it to be valid beyond 10 seconds. So I can specify an additional option here called expires in. This can actually be a string or an absolute integer number. For example, it could be 60 seconds when specified like this, or it could be 60 seconds when specified as a string, which is essentially 1 minute. Okay, it could also be something like 10 seconds, right? Or 1 day, right? Or 1 year. So let's try with 10 seconds. And what happens is that if you look at the previous instance, we had an IIT attribute, which is essentially an issued at timestamp for the token. And let's see when I do an expires in if it generates the same thing or something different. Okay, so I will go ahead and then clear the screen and rerun this. Okay, expires. Okay, I gave expires. It should be expires in. That was the problem. Okay, let me clear the screen and run it. This time it generates the token, and when we verify it, it also has an expiry date, right? So which is 10 seconds from the issued at attribute. So those are the important things that I want to show you before we move ahead with the next topic, which is signing and verifying with certificates. Let me go back to the diagram that it was earlier referring to. And if you look at this, so we have two kinds of tokens here based on algorithms. Obviously, we looked at the HS256 algorithm, and again, when I say HS256, it could also have 384 and 512 versions of it as well, and we looked at it as well, right? But we also have other algorithms in terms of RS256, which are predominantly for certificate-based signing and verification. In all the cases, the format of the token will be the same, which is essentially a base64 header dot a base64 payload dot the base64 HMAC of the header and the payload with the appropriate secret and the algorithm. Okay, which could be again SHA-256 or it could be RS-256 as well. To do this exercise, we need to do a couple of things. I'm going to open up my Docker terminal because I need to use certain utility related to SSL, Openssl to be precise. So I'm in a particular directory here, and to use the certificate based signing, first we need to use a command called Openssl, which I'll type in here shortly, and that will essentially generate the keys, right? And using those keys we can generate the private key and the public key. So first let's generate the private key, and then from that we can generate the public key. Let's generate the key bits. Could be anywhere between 512 to 2048. 2048 is the one that's very robust, so we go ahead and then take that. So here is the command. Okay, I'm going to type that command in here now. So Openssl So for this, you need the Openssl utility, which is generally by default available on Mac systems. For Windows, it is generally not shipped. You either need to install it separately, and I did it thanks to the Docker terminal that I had while doing some experiments in other topics. So that shipped with Openssl, luckily. So here is the command: Openssl gen p key minus the type of algorithm that you want to use, and in this case it's going to be RSA, and it is going to output us the private key, and I'll name that as private key.pem. You could name it any which way you want. And then there is an additional option for the key opt as well. There is a the key size, right? So you're gonna have RSA underscore key gen bits as 2048, which is the more robust one. So if you do a enter now, it'll generate a private key. So let's do an -LTR. It does. You can do a cat on this one just to see the contents of that. See, okay, that's the private key. Now that we have the private key, we can also generate a public key out of this, right? So, and we have an Openssl also comes in handy here. Openssl RSA minus, and the name of the public key would be public key.pem, for lack of a better word, public underscore key.pem. All right, so we must be having two files now, and we do. All right, so now that we have these files, we can use them in our exercises, and let's do that next.